So in this video we're going to build a Cardano relay node because Cardano's awesome, downright awesome, so fair enough. And we're following CoinCashew's guide for node version 1.26.1 and we've got a few additional things in here such as configuring a router for a bare metal pool setup, setting up Ubuntu's built-in firewall, UFW, updating a node from an older version to a newer version. And this video is basically going to speak for itself. I will interject at certain points where there needs to be some more information, but yeah, that's about it. So let's get into it. So on the subject of system requirements, you can run node version 1.26.1 on 4 gigs of RAM, but it's horrible and I wouldn't recommend it. Basically your computer will run like poos, especially when you get to the end of an epoch where the node really can use or wants to use more RAM. You'll find that it'll basically face plant at that point and slip into a coma. You'll have to revive it by, well, what I've done in the past is getting the blockchain off another computer, transplanting that, and basically restarting it and babysitting it. It's not ideal, it's not great. Even if you turn off TraceMempool and even if you increase the swap file size, it barely helps. And you'll find that your node is basically running on the ragged edge, and yeah, it's looking to trip over at any point. So definitely 8 gigs of RAM or more. Okay, so router setup. Once you've successfully hacked into your router using your official username and password, go through to the LAN section and then DHCP server section, and this is where you assign IP addresses for the computers that you're going to use on your stake pool. So each computer you'll want to assign an IP address. The reason for that is if your router is restarted or the power goes off, you don't want the router assigning another random IP address because that will break all the things and you don't want that. So the first thing we need to do is find the MAC address for the type of connection that you're going to use to connect to the router, which you should be using a wired connection, so Ethernet connection. So if you know your MAC address, you can put that in here. Ways to find it: you can use command line interface to find it. The easiest way, since you're in your router, is they often have a network map. So you can navigate through to the network map, see all the connected devices, and provided you're currently connecting to your router using the method that you're going to keep using for your stake pool, you can find your device on there, note down the MAC address, and then go back to the LAN DHCP server section and enter that in there with your chosen IP address. The next step is to open a port, and if you're running a relay node and block producer on the same local area network, then you only need to be concerned about ports opening from WAN. So your router doesn't care about internal ports, that's all unregulated usually, and it's only concerned about incoming connections. So what we're going to do is open ports only to your relay nodes, nothing else, certainly not the block producer. The default port that will be opening following the CoinCashew guide is 6000. So on a local area network, you'll have the block producer connected to the internal IP addresses of the relay nodes, and the relay nodes connecting to the internal IP address of the block producer. And those internal ports aren't being monitored generally by the router. So we'll look at setting up the UFW firewall, which is the inbuilt firewall on Ubuntu, and that will basically lock down all of the unused ports, just keeping open the relevant ports as another layer of security. You'll notice in the CoinCashew guide they've got different websites where you can check if your port is open or not. It won't work unless you're currently actively using the port. So if you open the port in your router and then go through to one of these websites, it's not going to successfully tell you that that port is open. It's going to basically have no result. If you are currently using that port using some software on your computer, then it will produce a correct result from one of these pinging websites. But otherwise, don't worry about the fact that those websites won't be able to see that the port is open. Just keep progressing in the guide anyway. Okay, so what we're looking at here is two out connections, two out pairs, which are the IOHK DNS connections. So they had a valency of 2, and applied to a DNS connection means that there's two connections. I haven't got this connected to my block producer, so normally you would have out 3 at this point, and in 1 if you've told your block producer that this node exists by updating your block producer's topology file. So basically everything under the out side of this is determined by your topology file, which we will sort out shortly in this video. What I'm going to do is change my port number and get my block producer to see this. So soon we'll have one in connection, and we'll go through, update the topology file system, which requires registration effectively with the system every hour, and after 4 hours you can then retrieve a list of IP addresses which will populate your out pairs, and the topology updating system will just automatically take care of broadcasting your IP address to other relay nodes, so that will sort out the in pairs side of this equation. it's always a good idea to button up your system as much as possible. So enabling the UFW firewall built in to Ubuntu is a good idea. Enabling that firewall will by default block all incoming connections. So first we want to open the port that the relay node uses, in this case 6001. Once open, we can enable the firewall. The computer will need a restart to enable it. And that's all we really need for the relay node. For a block producer node, you can get more complicated with it. You can specify the IP addresses that are able to access that port. So for example, if your block producing port was 6001, you could open that port only to the IP addresses of your relay nodes. So makes it that much more secure.